Hello everyone. We are continuing learning about creational design patterns, and today we talk about factory method. Last time we talked about the builder pattern, and I want to emphasize the difference between the builder and the factory method. The builder is normally used when a piecewise creation of a complicated object is involved. For example, there are many details involved in the production of your object, and there is a complicated sequence of steps that needs to be followed. That's when you use builder. Factory is a little bit different. Uh, what normally factory addresses is a situation like that. For example, you need to produce jeans, and that can be a complete factory for clothes. And you also need to produce a t-shirt, which is another concrete factory for clothes. And what can be the product in this case? Well, the product for concrete factory of jeans uh, is jeans, which is an abstract product in this case. Why? Because jeans can be of different types, and those would be concrete products. For example, I know, straight jeans or slim jeans. And the same goes with t-shirts. T-shirt can be an abstract product here on the left on my UML diagram, and the concrete product can be sleeveless t-shirt, can be V-neck t-shirt, and so on. So let's look again at this UML diagram. The question what is addressed by a factory, because what we produce, um, answer to this question gives a concrete factory. But first we start with an abstract factory. Abstract factory in this case is just an interface. Interface to create an object of a certain type, let's say clothes. And then we have a concrete factory. And the idea of the factory method is that abstract factory doesn't care which object user would like to produce. It's up to subclasses to produce it, and this production is done at the runtime. So concrete factory decides which concrete object, concrete product is going to be produced. And it basically creates that particular product. And that's why we have an arrow over here at our UML diagram. So we covered this part on the right, which is question what. The question how is addressed on the left. First we start with an abstract product, let's say jeans. And then we are talking about different types of jeans. A concrete product, let's say slim fit jeans. And the question how, well, you take jeans, you cut it on sides, it sort of becomes slim, and this is how concrete product addresses how question. In our example, we will be again continuing talking about high energy physics, so we will deal with an event full of different particles. Some particles will be interesting, some particles will be sort of junky. But the principle will be the same. Abstract factories, concrete factories derived from abstract, and they will be producing some products. And products, those are abstract products, and from them derived concrete products. Let's see how we do it. Let's jump straight to the code, and since we will be dealing with abstract classes, we need a couple of imports. So from abc import abc meta and also abstract method. Now what I would also need is to import system, and we are ready to start coding. First, we start with an abstract event factory, because for concrete implementations, we will have sort of cool event factory and also junk event factory, and you will see how it evolves. So let's start with an abstract event factory, and I would like it to be an abstract class, so I would need meta field to be initialized to ABC meta. That's the trick. Now, in terms of initializer, event. So, event should have particles. Let's have it like this. Self particles, and we will have several of them, so it's a list and empty list since an abstract class. Now, what I would also like to do, I would like to call a create event function inside of initializer, so it's like an obligation. That's why I put a call to this function over here. Now, this create event function that I just mentioned, and I put pass because I want to delegate implementation to subclasses. It also has to be overwritten, and what I would do, I would use an abstract method decorator. Of course, one could just follow an old style of not implemented error and put something like old style way to deal with purely virtual functions unimplemented. Let's add abstract method. So both ways are fine. I like a decorator more. Now, what else our abstract event factory should contain? Well, since we have a field, a list of particles, we would probably want to populate it, so I will call it add particle types, because it will be dealing with different types of particles, with Higgses, with W bosons, with electrons, and so on. And as an argument, when we add a particle, let's call it, for example, species. So what we will do, we will take self particles, and since it's a list, we will append species. And once we added particles, we would like to retrieve it back, and we would need a getter for this. Get particles, which implementation would be just a return statement of self particles list. And that's it. We are done with our abstract event factory. Now, let's go to concreteness. We need to know which concrete product to produce. So what I propose to do is a Higgs event factory, very specific implementation of a cool factory, of which would produce events that are really interesting, of really interesting physics. And also let's have something what is called junk event factory. All the electrons and then kaons and pions, well, maybe pions something like 50 years ago, that would be an interesting physics, let's say VA theory. But right now is an era of Higgs physics, pions are not that interesting. And I have prepared already a useful copy-paste, and those specific classes of concrete factories I already had in that file. Just to recap what we do here, in our Higgs event factory, which is derived from event abstract event factory, we override create event function. And what we do basically in this function, we add particles of different types to our event based on what kind of factory it is. Since it's a Higgs event factory, we add Higgses, but also W's. Those are sort of cool particles. But if it's a junk event factory, we add electrons, pions, and kaons. Those sort of junky particles that we don't really care. And this is where the magic happens. It's a create event over here that does the work. We are creating a specific product, a specific event. And this is basically the brilliancy of the factory method. Abstract factory doesn't care which object you create. It delegates it to a concrete factory who decides what to create. And it's done inside of concrete implementation. Alright, so far so good. We are done with the right hand side answering what question. Now let's answer how question. How we gonna produce those particles? Well, first we need abstract particle class, right? This abstract product on the left hand side, and this abstract particle class, again, it should be abstract, so don't forget this magic line. Now we go with initializer. Okay, it's some type of a particle. So let's have the field particle, and by default let's keep it to none. Now, when I call, let's say, abstract particle name, I would like to not just produce me an instance, but to return it back with a call operator. So for that, I would like to override a call method. Actually, it suffices like this. And the return of that should be very simple, just the particle itself, just the object. So when we would use a function call operator invoked upon this class, it would return an instance of the object itself. Alright, now for nice printing, I would like to override also string operator, and it would return basically the same, because we will be dealing with strings that are produced using electrons class and pions class and kaons class, and if not, we would have to maybe call here a string function, but we don't need to. Okay, so we produced init, call, and string functions, and that's it. Now we can go into concrete implementations of particles, in other words, concrete products. And now let me go back to useful copy paste and get those classes for you. So class W's, it inherits from abstract particle, and what it does, it just sets initializer internal field particles to the string W's, and that's why here our printing will be already done properly. We don't need anything extra. And the same for Higgses and for electrons, pions, and kaons, exactly the same logic. Now, after we are done implementing concrete products, those are concrete particles, let's define finally a main function. So we would like to deal to be able to produce different factories and sort of keep it interactive. So we would like to ask a user what kind of event is of your interest. So we would ask for raw input, something like this. Maybe please enter which event you would like to produce, Higgs event or chunk event, like that. Now, of course, user may type it in with an error, and we would like to avoid it. And there are different ways. Maybe the first that comes to mind, we will address it with a while loop. So we have event of interest plus factory. While this string, this combined string, is not in the following options, which is Higgs event factory or junk event factory, then we basically gonna repeat, and we would say event of interest, again raw input, and we would say please try again to enter which event you would like to produce without typos. And let's add Higgs event or junk event. Okay. Now, after we managed to assign some string to the variable event of interest, what we can do, we can finally create a factory object with the help of a magical eval function. So we will take event of interest, we would add factory, and now adding this function call operator, as I mentioned a couple of minutes ago, when we were overriding a call, this would return us immediately an instance of the class, which is great. We would have specifically either a factory for Higgs event or for junk event. Now, after we've done with the factory, what will happen? Factory, as we discussed, it will produce concrete products, concrete events, because it will call automatically, because we had it in our abstract class, our panel class initializer, it will call automatically create event. And this create event will decide, and this is addressing how, which is how to populate our event, what to add there. Well, Higgs event will add W's and Higgses, and junk event will add electrons, pions, and kaons. And this is how question is addressed. Okay, factory will do the work, will create our event full of particles. Now let's get the particles back. So our event will have factory get particles, and get particles will return us a list of particles that it produced, and if it has W's and Higgses, then it means we successfully produced through Higgs event factory on an interesting event, and if it has electrons, pions, and kaons, then through junk event factory we produced sort of uninteresting event. And let's add some printing. Event contains this particles event. And that's it. Now we can call our main function. Let's use a standard name main idiom. By the way, what basically this line is doing, it's a common way of running code only when the module is run as a script as opposed to being imported. And with this following line, we add our script. We end our script. Well, actually, what we can do, we can make it a bit modified with the following addition. So you see, we will call main, and it will get passed to exit function inside of the sys module. And so this sys exit main that we use means run the main function and exit with the return code returned by the main function. And it's sort of a common idiom so that when running a script from the shell, you can tell reliably if it succeeded or not. Very useful thing. And now finally, let's run it. And you've got a question. Please enter which event you would like to produce. Well, just for fun, let's make a typo. And it asks us again, please specify. Well, we say fun squared. And it asks again. But finally, we are tired of these jokes with an REPL, so we put Higgs event, and it gives us the event contains these particles, and you can see W's and Higgses. So this basically how we address the problem when we need to create different objects. Those would be different products, if you wish, and it's an answer to the question how. We start with an abstract product, and then implementation follows in a concrete product. And in our case, we had abstract particle and specific concrete particles inheriting from that. And what question, which is a decision what to produce, we address here on the right. We started with abstract factory, and with a concrete factory, we specify what exactly we would like to have. I guess that's it. Also, we had this loop just to make sure what user puts as an input is valid. Thank you for watching. Stay hungry, stay humble. We will continue next time.